Welcome to Practical Work Number 1, Algorithm and C Programming Basics. Today, we transition from theory to practice. First, we will install and configure the Dev C++ environment. Then, we'll tackle real problem analysis, defining your inputs, processing, and outputs. You will write your first programs to calculate geometric areas, swap variables, and convert temperatures from Celsius to Kelvin. Open Dev C++, and let's start coding. Exercise 1. Geometric Shape Calculation. Objective: calculate the perimeter and area of a shape consisting of a square, side C, with 4 semicircles attached to its sides. 1. Problem analysis. Inputs: the side length of the square, C. Processing: O perimeter. P. The perimeter consists of the circumferences of the 4 semicircles. Mathematically, 4 semicircles equal 2 full circles. The diameter of these circles is C. Formula: P equals 2 times pi times C. O area, A. The total area is the area of the central square, plus the area of the 4 semicircles, which equals 2 full circles. Formula: A equals C squared plus 2 times pi times C over 2 squared. Outputs: display perimeter P and area A. Explanation. The program defines pi as a constant. It takes the side length as a float input. It calculates the perimeter as the circumference of 2 circles, since 4 semicircles equals 2 circles, and the area as the square's area, C squared, plus the area of 2 full circles with radius C divided by 2. Exercise 2. Weighted average calculation. Objective: calculate a student's average for the Arithmetic module using fixed coefficients. 1. Problem analysis. Inputs: exam mark, IBD exam, TP mark, TPM. Processing: O exam coefficient, 0.6 OTP, coefficient, 0.40 formula. AVG equals open parenthesis XM times 0.6 close parenthesis plus open parenthesis TPM times 0.4 close parenthesis. Outputs: the calculated average, AVG. Explanation: the coefficients are declared as constants to ensure they don't change during execution. The program multiplies the exam score by 0.6 and the practical work, TP, score by 0.4. Then sums them to get the final weighted average. Exercise 3. Arithmetic operations. Objective: perform basic arithmetic on 2 integers. 1. Problem analysis. Inputs: 2 integers x and y, where y greater than 0. Processing: O sum, s equals x plus y, O. Difference: d equals x minus y, O. Product: p equals x times y, O. Quotient: q equals x divided by y, O. Remainder: r equals x modulo y, y. Outputs: display s, d, p, q, r. Explanation: this exercise demonstrates standard arithmetic operators. Note on division: since variables are integers, int, the division x/y will result in a whole number, truncating any decimals. Note on modulo: the percent operator provides the remainder of the division. Question from text: if the 2 numbers are real types, floats, what needs to be modified? O. Answer: you would change the data type to float or double. The remainder operator percent cannot be used with floats. Calculation of quotient would result in a decimal value rather than an integer quotient. Exercise 4. Digit repetition expression. Objective: calculate the value of n plus nn plus nnn for a given single-digit integer. 1. Problem analysis. Inputs: integer n between 1 and 9. Processing: O construct, nn equals n times 10 plus n, O construct nn equals n times 100 plus n times 10 plus n, O total. Result equals n plus nn plus nnn. Outputs: display the result calculation. Explanation: this exercise uses mathematical place value to construct larger numbers from a single digit. If n equals 5, nn equals 5 times 10 plus 5 equals 55. nn equals 5 times 100 plus 5 times 10 plus 5 equals 555. Result equals 5 plus 55 plus 555 equals 615. Exercise 5. Temperature conversion. Objective: convert Celsius to Fahrenheit and Kelvin. 1. Problem analysis. Inputs: temperature in Celsius, T, C. Processing: O Kelvin, TK equals Tc plus 273.150 Fahrenheit. TF equals 9/5 times Tc plus 32. Outputs: display TF and TK. Explanation: the code performs standard conversion. Critical detail: in the C code provided in the source, the division is written as 9.0/5.0. This is crucial because writing 9/5 in C results in integer division, which equals 1, causing an incorrect calculation. Adding the point 0 forces the compiler to treat them as floats. Exercise 6. Power and square root. Objective: calculate the square root and fifth power of a positive number. 1. Problem analysis. Inputs: positive number n. Processing: O square root, SR. N skirtuentrans, O power, P5, N5. Outputs: display SR and P5. Explanation: this exercise introduces the library. Square root of n computes the square root. Power of n to the power of 5 computes the base n raised to the power of 5. Exercise 7. Variable permutation, swap. Objective: swap the values of two integers a and b, 1. Problem analysis. Inputs: integers a and b. Processing: use a temporary variable c to hold the value of a while swapping. OC equals AOA equals BOB equals C. Outputs: display a and b after the swap. Explanation: to swap two variables, you cannot simply say a equals b and b equals a, because the first step, a equals b, overwrites the original value of a. You need a temporary container, variable c, to save the value of a before overwriting it. Exercise 8. Digit extraction. Objective: separate a 3-digit integer, 100 to 999, into hundreds, tens, and units. 1. Problem analysis. Inputs: integer n between 100 and 999. Processing: O hundreds, H, n divided by 100. Integer division drops the last two digits. O tens, T, n modulo 100, divided by 10. Get the last two digits, then drop the last one. O units, U, n%10. Get the remainder of division by 10. Outputs: display H, IT, U, explanation. This relies on how C handles integer math. 258 divided by 100 equals 2, hundreds. 258% of 100 equals 58. Then 58 divided by 10 equals 5, tens. 258% of 10 equals 8, units. Exercise 9. Time conversion. Objective: convert a duration in seconds into hours, minutes, and seconds. 1. Problem analysis. Inputs: duration in seconds, ds. Processing: O hours, h, ds divided by 3,600, since 1 hour equals 3,600 seconds. O minutes, ohm, ds modulo 3,600 divided by 60. Take remaining seconds after hours are removed, then divide by 60. O seconds, s, ds %60, the remaining seconds. Outputs: display in format H:(M:(S). Explanation: this logic breaks down the total seconds hierarchically. First, calculate how many full 3,600 second blocks, hours, fit into the input. Then, use modulo % to find the remainder. Calculate how many full 60-second blocks, minutes, fit into that remainder. The final remainder represents the seconds.